In this centripetal force problem, we have a 29.4 kilogram girl who sits in a tire that is attached to an overhanging tree limb by a rope. The girl's father pushes her with a linear speed of 2.5 meters per second, so that she travels in a horizontal circle with a radius of 2.1 meters. What is the centripetal force acting on the girl? So in this problem here, we have our tree limb. And then we have the tire rope here. Then the girl sits inside the tire. And it's going to swing in a circle like that. Now we are told we have a linear speed of 2.5 meters per second. And linear, in this case, is the same as tangential. Again, we have two different types of speed, and understanding the connection between the unit and the symbol is very important. If it is a meter per second, that's a clear indication that we are a linear or tangential velocity. And if we are radian per second, that is a clear indication that we are an angular speed or angular velocity. So because we are given it to be meters per second, we know it's a v sub t instead of omega. We're also given the 2.1, which is the radius. And we want to know what is the centripetal force acting on the girl. So we are looking for a force, subscript of c, for centripetal. Now, first thing we have to do is we have to solve for the centripetal acceleration. And there's two formulas for centripetal acceleration. Because we are given v and r, we want to use the first formula, v squared over r, instead of the second one, r times omega squared. So making sure you get this correct in your givens will ensure that you pick the right formula for your centripetal acceleration. We have our tangential velocity of 2.5. That number is squared, divided by our radius of 2.1. We get a centripetal acceleration of 2.98, and that will be a meter per second squared. Again, whenever it's an English letter A, just like we always used in the past, it will be a meter per second squared. Doesn't matter the subscript, as long as it's the letter A, the units are always meter per second squared. Now we're going to take that and solve for the centripetal force, which is the mass times the centripetal acceleration. We have the mass at 29.4. The acceleration we just got to be 2.98. And that gives us a centripetal force of 87.5. Now, all forces, no matter what type, whether it be gravitational force or tension force or frictional force, they are always the same units, and that is newtons.